Hey everybody. So this is a screencast to help just with a little extra practice with these circuit Sudokus. So I have the extra practice sheet that was provided to you, and sort of just going to talk you through the four problems. Try to go a little quick, but hopefully not too quick. The nice thing again with these is you can always pause and rewind and go from there. All right, so we have this setup. We have six resistors plus the battery. And we have certain values that are given to us. The total voltage of the whole thing is 200. We know R1, we know R6, we don't know a whole lot of else. Alright, so a couple things. I'm seeing R4, and this is R4. I'm just going to make it a little bigger so you can see what these are, because these are a little small. So those are just the values of the resistors. So resistor 1, 2, 3, 4, 5, 6. Alright, so the first thing I look for parallel voltages that are real simple. Nothing real simple here because I have series pieces in between my two dots. So I look at those two dots and I say, well, the current of series must be the same. So the current of R2 and the current of R3 is the same, but I don't have that. But for the same reason, the current of R4 and the current of R5 is the same. And I know the current of R4. So that tells me it has to be also 1.21 amps for the current of R5. And anytime I know 2, I can find the third. So I can find V5. V5 is going to be 10.5 times 1.21. So that's 12.705. I'll just do 12.71. 0.71. And while I'm at it, I know V of 1 and R of 1, so I can find the current through resistor 1, 70 divided by 18, which is going to be 3.88. Okay, next thing I look for. So I now have the current through R4 and R5. The next thing I look for is I'm looking to see what this 3.8 is. I just calculated it, so what does it really mean? Well, it's the current that must be coming out of the battery and going through R1, but then that current's going to split into two pieces, the current that goes through 2 and 3 and the current that goes through 4 and 5. So if there's 3.88 going here and 1.21 going here, well then the rest of that 3.28 has to go down the middle. So it's going to be 3.88 minus 1.21, which leaves current through 2 and 3 being 2.67. And it's the same current, so you definitely don't divide by 2. On these, you're never going to divide by 2 when filling in these boxes. The only time you would divide by 2 is if a value of 2 is either in I or R. Alright, so then I have the 2.67 and the 7. I can multiply that to get V2, and that's 18.69. Okay, so we're good there. Now, my current comes through. I got the 2.67, I've got the 1.21, and it recombines. So it has to recombine what came in, 3.888, or 3.88 has to recombine back to the same 3.88. So my resistor 6 has a current of 3.88. And that same 3.88 has to come back to the battery. So that's also 3.88. So I can find my resistance of the battery. It's going to be 200 divided by 3.88, which is 51.55. 51.55. And I can also do 6, so that's 100 divided by 3.88. So that's going to be 25.77. And we're good. So now I have 3 and 4 that I have to figure out either their voltage or the resistance. And I look and I say, all right, well, the total voltage for any loop has to add to 200 because 200 is my battery. So that tells me that I'm coming out of the battery. I'm going to follow one loop. My first loop is R1, R2, R3, R6. So the voltage of R1 plus the voltage of R2 plus the voltage of R3 plus the voltage of R6 has to equal 200. But I know R1, I know R2, I know R6. So I can find R3 by adding 70 plus 18.69 plus 100 and then subtracting that number from 200, and I get a value of R3 of 11.31. And I do the same thing for my outer loop. I know that 200 equals VR1 plus VR4 plus the voltage of R5 plus the voltage of R6. And for the same reason, I'm able to find the voltage of R4 because I know 1, 5, and 6. So that's 70 plus 12 point, I hope that's 71, plus 100, and I get 182.71, subtract 200, or subtract that from 200, I get 17.29 volts. All right, and then my final step is simply do 11.31 divided by 2.67, 4.24, and 17.29 divided by 1.21, 14.29. And I am done. All right, so the key thing is R2 and R3 have the same current, R4 and R5 have the same current. The two currents, whatever those two are, have to add to what was coming in, and we went from there. So good job. Let's move on to the next one. So this next setup has 5 resistors, and we have certain information just like last time. And right away, I know not a whole lot. I know that 6 divided by 15 is something I can calculate, so I'll do that. That's 0.4. And I say, well, if R3 is 0.4 amps, because R2, R3, and R4 are all in the same line, so it means they're all series current, that means that R2 is also 0.4, and R4 is also 0.4. Which means that the rest of the current has to, you have 1 coming out of the battery, which means, while I'm at it, 1 has to go through R5. 1 comes up, it splits, 0.4 goes down this way, so 0.6 has to come down this way. So that's 0.6. And then I'm going to fill in the ones that I have doubles of. 0.4 times 10, well that's 4. That's simple enough to do in the head. 25 divided by 0.6 gives me 41.67, and 2 decimals is fine. And 20 divided by 1, simple, is 20. Alright, so I have 4 boxes left to go, and I'm looking at voltages. I know that R1's voltage, because these are parallel, I know that the voltage of R1, because R1 is parallel with those 3 combined, has to equal the voltage of R2 plus the voltage of R3 plus the voltage of R4, because those 2 are parallel. This leg is R1, the other leg is R2, R3, R4. So that's 25 equals, well, I don't know voltage of R2, but I know that voltage of R3 is 6, and the voltage of R4 is 4. So I know that 25 equals VR2, the voltage of resistor 2, plus 10. VR2 equals 25 minus 10, which is 15. So this is 15. And I also know that each loop has to add to the voltage of the battery, so I'm going to try to find the battery. And I'm going to take a simple loop. It's my outside loop, so it's R5 plus R1 all the way back to the battery. So the voltage of R5 plus the voltage of R1, voltage of the battery, is the voltage of R5 plus the voltage of R1. And R5 is 20, R1 is 25. So my battery is 45. 45 divided by 1 is 45. 15 divided by 0.4 is 37.5. And we're good. Alright, so the key thing here, R2, R3, R4 are all parallel. RL series in parallel with R1, and you're working through that current. Perfect. Moving on to number 3. Again, a little quicker. Pause when you need. Think about it. I know that R2 and R3 are parallel. There's only one set of connections between them. The current has to split. So R2 and R3's current has to add to R1. So I know that the current of number 1 is 13. Alright, so 60 divided by 13, 4.62. 4.62. I know that, let's see, where am I going here? I know that the battery, following one loop, I'm going to follow the outside loop, hits R4, goes back into the resistor, so the battery's current, voltage, has to be the same as R4, and that's 175. So I'm just looking for things I know. 175 divided by 8.75 gives me a nice value of 20. So I know that there's 20 amps coming out. 13 of those amps go this way, which means that 7 amps has to go down my R4 leg, so this has to be 7. So then I get 175 divided by 7, which means a resistance of R4 of 25. Moving right along, I know that other loops, R1, R2, has to add to 175. R1 is 60, because the voltage of the battery is going to be the voltage of R1 plus the voltage of R2. So that's 175, that's 1, equals 60 plus VR2, which is telling me that VR2 is going to be 115. And because these are parallel, they have the same exact voltage. These are parallel. They have the same voltage, so that's also going to be 115. And then I can finish up just using Ohm's law. 14.37 and 115 divided by 5, 23. Perfect. Last one. Try to do it real quick before my time runs out. I have 20 times 2.4 is 48. 48. I know that R5 and R2 are perfectly parallel with each other, so R2 is going to have the same voltage. That's 48. 48 divided by 15 gives me 3.2. I know that R3 and R4 have to add to 48, but I don't have any other information quite yet, so I can't do that. But I do know that R4 and R3 have the same current because they're in series, so that's 1.7. So 1.7 times 15 gives me 25.5. So R4 has to use the rest of that push, which is going to be 48 minus 25.5, so that's 22.5. Which tells me 22.5 divided by 1.7, the resistance is 13.23 ohms. And I know that the battery has the voltage of R1 plus the voltage of R2, so the battery is a 248 volts. And coming through R1, I have the current, so the current through R1 has to be what has split off into the current through R2 plus the current through R3 plus the current through R5. I don't use both of these because they're on the same leg. They're sharing that current. So it's going to be 3.2 plus 1.7 plus 2.4, which gives me a current out of 1 of 7.3. And because 1 and battery are in series, that's also 7.3. Do my final checks to finish. My effective resistance is 33.97 and 27.4.